Thanks for having me. It's a great honor to be here. I'm Yuchen Fara, and I'm Director of Product at Clarifai. And today I'm going to give a quick talk in terms of building a high-performance AI-powered applications in minutes in a really low-code, no-code way as we're revolutionizing AI for everybody. So just a really quick background information on Clarifai. Clarifai is a leading independent provider of artificial intelligence for structured and unstructured data, such as video, such as text. And we have end-to-end computer vision and NLP platform that covers the entire AI lifecycle, from data labeling to training to model development to deployment, all in one platform. So let me gonna go through just a quick overview. So the company was founded in 2013 by our CEO, Matt Ziller, after he won the ImageNet competition in 2013, which is a very prestigious competition. And since that, we have won several awards, and most recent is the Forrester, as you see on the upper right-hand corner. We were recognized as one of the big four of computer vision platform, and the other three are Google, Microsoft, and AWS. So this evaluation really says a lot about our kind of our status in the computer vision market. And since then we have grown into 100 employees in our headquarters in New York City. We also have office in San Francisco, in Tallinn, Estonia, and Washington, D.C. And we believe that we offer a unique perspective as one of the kind of early movers in AI space, and we have tons of experience working with AI solutions in not only enterprise, but also public sectors, such as Department of Defense. So for today, I'm going to give a really quick overview of basically our platform end-to-end lifecycle, and then I'm going to dive right into the demo, kind of really hands-on experience of building, labeling, building AI models really in minutes in a low-code and no-code fashion. So also just want to quickly point out that we are really differentiators in the space, in the sense that we have really the fastest time to value. Oftentimes we hear data scientists or AI practitioners, they have really just spent so much time in terms of managing the unstructured data, the labeling, the annotation, also bring it into the model development and stitching together different tools. So we abstract away all the plumbing, all the complexities, and have really full, very elegant kind of an API on top, and also a web GUI on top, so that it's a one-stop platform for every step of AI lifecycle, and really kind of maximize that time to value for unstructured data. And also because we're independent from all the cloud providers, so if you want to have a solution that doesn't depend on any kind of big cloud providers, we also have pretty much we're the Switzerland in terms of the cloud AI wars, and we also develop our platform in air gap, bare metal, and also at the edge, different environments. It's also very easy to use, which I'll show you very soon. How to build things in a really kind of no-code, low-code fashion. And also we have 8 years of AI leadership across really one of some of the largest commercial companies, like say Fortune 50 companies and government organizations, a lot of kind of public sector projects. So here is really a quick kind of overview of what we mean by AI lifecycle. So if you think about kind of our platform and our product, we have roughly 6 products. Scribe is our labeling product, but it's not just manual labeling. Of course, we offer human label force. We also have automated machine labeling. For example, you can set up AI assist and active learning so that you can use well-trained model to help you label, and then you can help you label when the confidence score is high, and then you can kind of branch out some of the low confidence scores for human labelers. So we have a pretty nice kind of integrated active learning for more automated labeling for Scribe. This is one of our product lines. And then moving to space-time, so that's our AI-powered search for unstructured data. When we talk about image search, especially in the kind of a high-dimensional vector space, we have very powerful kind of search algorithms that really kind of give you kind of massive lightning speed search experience, which I'll demo very soon as well. to do visual similarity search. And again, we work with Fortune 50 companies such as Lowe's to do kind of a really kind of industry-leading search benchmark. And moving forward to Eli, so this is our product line that basically we not only provide pre-trained models, but also we provide transfer learn models on top of our general embedding model. And also we provide the deep train model if you want to train the entire network from scratch. So depending on how many kind of, how much labeled data you have or how much compute resource you want to spend, we offer a variety of solutions for you to train models. And Amarda is our predict. We also have very powerful kind of a predict, inference engines. We can easily scale to, up and down. We can scale to thousands of servers, and we manage all the infrastructure, so you don't have to worry about, what needs to be done under the hood, and you can easily deploy, deploy, like, for example, thousands of models and scale your inference that way. So that's our Amara product, and Mesh is workflow. So the power of AI oftentimes is not just a single model, it's actually the ability of stitching together several models. For example, if you have a number of images and you want to detect the person, but then you want to crop out the face of the person, and then later on do classification on that face, based on, say, gender or demographics, so you can do it that way. So you can build on top of your workflow. Another example is you could use OCR, and then you run basically your OCR model on a number of images, and then you can run your text recognition workflows on top of extracted text. And then downstream, if you want to run, say, text moderation or text classification, you can build on top of that. So workflow is pretty powerful, and we have very easy to use GUI for you to kind of drag and drop different models into different nodes and build on top of each other. Flare is our edge product. So currently we deploy kind of NVIDIA hardwares, but we're also expanding to kind of other possible, hardware and AI chips. And we can deploy our model to anywhere from a thick edge servers, such as like a laptop or edge server like x86, to a really small, thin embedded device on top of ARM kind of architecture. For example, Xavier, AGX, and NX. And the entire platform is pretty scalable in a way that we can, have just run the inference on the edge, or if you want to train and then do search on your edge server, but then you run inference on the thin edge, we support it that way. So it's very composable platform for people to customize, and then it's also very pluggable as well. So that's our edge offering. So yeah, basically this is the entire kind of a platform product suite we offer, and we deploy everywhere, as I mentioned, to cloud, to bare metal, to basically air-gapped scenarios. We have security, like lots of clearance, because we work closely with many kind of public sector departments and their projects. And so we're happy to kind of also bring the best practice to the rest of the world. So that's pretty much a nutshell of the platform. And now I'm going to do a quick demo. So first of all, what I'm going to demo is really the journey of many people who want to get started with AI, especially developers who do not have machine learning expertise or a lot of AI experience, but they just want to get something started quick. But then later on, kind of moving on, once they are comfortable with using pre-trained models, then we have transfer learn a capability. So basically, we have the entire kind of network, but then we kind of take out the last layer. So you only need to train the last two layers based on, say, a couple dozen of labeled data. Then you can easily build a transfer learn model just in minutes, just GUI drag and drop tool. So I'm gonna demo that, and after that is people mature, after comfortable with transfer learn, if they want to do deep train. If I had time a little bit later, I can quickly just show very high level how that is done in the platform. So in terms of I'll start with the pre-train model. Let's just say for developer who want to try AI but do not have any experience building AI models, I would say my recommendation is go to Google and search Clarifai's model gallery. So what I'm going to search is base model Clarifai. So as you see, we have, of course, our face models here in our model gallery. And you could try your own image, or you can just scroll through and see what our kind of a face detection model looks like. And we also have landmark. We have the pose and a lot of kind of rich features. Feel free, after the talk, if you want to try your own image, you can put the URL, or you can upload the local file and then just play it that way. But it's not just we offer. We actually have a rich suite of models in this model gallery. So if you go to product and go to model gallery, again, this very soon we're going to be replaced by our community, where we have a slightly different interface for you to search, because as we grow models to hundreds of them, it's much easier when you have like a search filter, almost like an e-commerce interface to find what you need. But for now, this is what we have. And so what I just showed you is the face model, face detection model. But we also have a number of models, and what I'm going to show you is really our general model. So this general model is really the great-great-grandchild of the model when our founder and CEO, Matt Ziller, won the ImageNet 2013 competition. Since then, we have multiple kind of iterations on this. And let's just see okay, let's see my mouse. There you go. Here, scroll down. As you see, it recognizes, again, this model has over 11,000 concepts. And we also have 23 different languages. So here, as you see, it recognizes, the concepts on this image. But also, it's not just the object, it's the higher level emotion set of it. So this is an example. As you see, you recognize love, affection, romance, togetherness. So this is really kind of the next level of AI beyond what just computer sees in terms of the object on the screen. So this is very interesting. And we also have the ability to support videos. So we can do, in this case, I'm going to play this video. Hope the sound. Fast forward. This case, as you see, now this is the more predictions on the lake and the mountains. Okay, now I'm going to pause. So this is also an interesting example, and I'm going to show you one more on the pre-trained model, which is our moderation model. So oftentimes, especially in the e-commerce or digital asset management space, there's a need for moderation, not safe for work. So we also have some examples of that. And as you see, whether it's safe for work or not safe for work, and then some of the score for you to kind of make sure, to screen out the image that are not appropriate. So these are all our kind of model gallery. So how do you kind of use and build it? Next, I would say, feel free if you actually want to use our platform. If you want to just say, start for free, you want to say register, it of course prompts you to sign up. It takes 10 seconds to sign up account. After you sign up, you can create your own apps. And apps is really our highest level container. If you say you want to upload image, you want to upload videos and audios, like in this case, this is one of my app. You can upload many different, you can set up your API keys here. Oh, sorry. You can have your API keys, and you can add different collaborators to your app. And then you can upload your input, whether it's image or text or audio. We support those, and you can start to explore and build models. And you can also set up a large scale labeler task as well, which I'll touch base a bit later. So this is really kind of a platform in a nutshell. Of course, behind the scene, we have all the APIs. So we have docs.clarifai.com. If you are interested in all the APIs, but just you don't want to use GUI tools, we have all pretty detailed documentations on using our APIs. And you can also come here to our clarifai.com, to see some of the developer documentations on API as well. right here, the API reference. But today I'm going to show you kind of really quick way of building things in a very low kind of code, no code way. So first of all, as I mentioned earlier, we have a number of preview models, but oftentimes people find preview models are limited, especially when we're solving your real world problems. And one size fit all model is not always kind of easy to kind of serve all the use cases. So what we do is that I'm going to show you really quick how to build a custom model. But before that, I want to kind of give you a quick overview of what could be done in our platform. So right now, I have several apps here. They all kind of represent different examples. For example, if you have lots of image input, as you see, we are really building, real world kind of apps with, say, thousands of concepts. It's not just a toy app, for prototype. You can build the real world apps, and then you can, you can basically create different concepts, and then you can start to label your image based on the concepts you have, and you can train models. In this case, we build the appliance example for Lowe's. And then you can click into each of them and understand a little bit more details. But I also want to show you here is another app. Oh, let me just refresh. I think I just pinned the app. There you go. So there's another example of OCR, which is, in this case, it's not just kind of a computer vision app. It's actually kind of from computer vision to kind of the text extraction piece. So it's optical character recognition. So in this case, let's just say I have a license plate here, and I want to kind of extract basically the text on top of it. So we have a kind of a workflow, OCR workflow that does that extraction. So we'll just give it a couple of seconds. There you go. So basically here you can select different workflows. In this case, I select just a very general kind of visual text recognition workflow. And of course, you can select other workflows if you want to try it. Let me just scroll down a little bit. And as you see at the bottom now, we extract different pieces of text from this license plate. And the nice thing is also, you can build downstream workflows if you have, say, text classification or NER, which is name entity recognition. So this is a very simple use case. But also, I want to show you, besides license plate, it has so many other use cases with OCR. You can go to here. So this is also interesting kind of OCR use case. From social media entertainment perspective, you can extract the text there, and also, of course, you can also label the image and also the celebrities and then text around this. So that's also a pretty interesting use case. And another interesting use case is the commercial packaged good, where this is my favorite, protein powder, and then you can have basically the extraction of all the text on top. In this case, let me just change my mouse a little bit. There you go. Yep, it basically does a pretty good job extracting the text from it. So this is a OCR kind of a use case. So before we mentioned the image, and then now we get into the OCR, and then if you extract the text, then the next step is building natural language processing apps. I also want to show you a quick example of basically, I'm going to go back to my applications, and we also have text moderation here. So this is an interesting NLP use case. Of course, in the data upload kind of step, you can upload not just images, as I mentioned, you can also upload text as well. And in this case, we have a simple model basically that does text moderation. Again, you can create many different models and workflows. In this case, as I see, I have way too many, but I'm not gonna get into it. So for text moderation, in this case, you can see like in this is pretty neutral. it's not that bad as you see, but then as you get into this piece, now you can see it's pretty bad, it's toxic, it's pretty insulting. So that's a standard use case of text moderation. On top of this, we also have other type of text, NLP kind of templates. For example, you can build the workflow for name entity recognition. You can build the workflow for text classification, and but moderation we found oftentimes is very, very helpful use case. That's why I could demo this one. So that's pretty much a couple of interesting use cases we have here. We also have people who build apps for a really kind of large scale video as well. So this is a interesting example we did for, of course, public sector. I'm not going to get into the details of it, but this is really to, surveillance to ensure the safety of our deployed crews. As you see, we have lots of videos here. We also does, video labeling and modeling and deployment as well. So this is another example here. Okay, so so far I have demoed several use cases from consumer goods or to in the image, in the video, but also the OCR and the text moderation and some of the video capabilities. Next, I want to kind of just move on to the next step, which is training custom models. So as I mentioned, pre-trained model is very helpful, but with custom trained model, we suddenly unlock so many different use cases, as I just demoed before. And to build a custom trained model oftentimes is difficult because of several reasons. People could either just don't have a lot of labeled data, or it takes too much work to understand, say TensorFlow, PyTorch, and load all the packages and making sure things are working. And then going back to your labeled data, and then going back to the model training codes. There are a lot of kind of pipeline plumbing. There are a lot of kind of friction of stitching together different tools. And our platform actually made it very, very easy for you to do. In this case, let's just say, take an example here. People professional. So this is really what I just made last night, this quick app. So when you can easily just add your input here. As you see, I added about 621 input last night. And you can see the inputs here. Basically, I want to build a quick model that just differentiate between factory workers versus skaters versus tennis player and waiter and waitress. So I have a number of things here, just a bunch of images I uploaded from different professions, and I create this for concept. And I'm going to show the counts here. As you see, I already labeled some of them, but then instead of label one by one, actually our platform made the labeling so easy that you can easily, you can basically, leverage our visual search to do the bulk labeling. So what it does is, let's just say I'm interested in labeling skaters. And in this case, I will just pick a really good example. Like in this case, I'll click this button and it will search all the visually similar input to this skater. It's a little bit slow today. Usually it does image search pretty quickly. Okay, let me just try to refresh. Okay, there you go. So you can do a bulk label, just click Shift, and then in this case, as you see, it's pretty good in terms of identifying visually similar kind of inputs for skaters. Well, as you get, also it's interesting, these are all more like a professional, but then the algorithm does a pretty good job. Now it's really just people who are doing recreational piece. So all the way here, I'm gonna hit Shift and click this. Then I can just do a bulk label. So after I select those, I can label them as skaters in this case. I'm not gonna label them again because I already did. But this is, as you see, it's pretty powerful to do this bulk label. And the next step, for example, I want to also say tennis player. So for tennis player, similarly, let's just say I want to pick a really good representative tennis player, professional kind of image. In this case, maybe I'll just use this one. Okay, now it's working pretty well. As you see, on top, it has very similar professional kind of tennis player. And when you get to scroll a bit down here, okay, then you get to people who are, okay, there you go. This is interesting, definitely not professional tennis player, but as you see, this is not really tennis. Now you get into the table tennis piece. So it does a pretty good job, kind of, now it's soccer. It does a pretty good job in terms of kind of identifying, most similar image for tennis players. So I would do the same thing. You can do the click, the inputs, and then you can basically do a block label that way. And then you can also, besides block labeling, select tennis. You can also add metadata as well. If you say this is going to be my training image, it's a train, and yes. Or if you want to, carve out a special kind of standalone text image, you don't want to get contaminated later on. You can do like a text image. So later on, you can search on the metadata right here based on what's your input. So it's also very helpful as well as you develop your model and workflow. So after I did all the labeling, what I can do is instead of visual similarity search, now I just want to search, say, 28 labeled, possibly labeled skaters. I can click this button. Then you can see a much cleaner version of all the labeled kind of images I have in commercial, professional, or skaters. Okay, so that's the first step, is the labeling. Next step is to train the model. And we do have so this is our Explorer mode. And again, if you want to check the annotations, you can also do a single image view. If you click in any of the image, you can see the annotations. Oftentimes, you might have collaboration with many people, and you should be able to see, who labeled what. And in this case, just myself. But if you have other collaborators or labelers, you should be able to see how many people label this concept versus the other one. Later on, I'm going to get into the labeler mode, but I'll mention that a bit later, save that for a bit later, because itself is another standalone pretty big topic. So in this case, it's classification. You can do, you can also add concept that way, and you can see some of the model predictions. You already have a existing model. You can see the model prediction as well. But in this case, because they're already labeled, so of course the prediction score is 1. But later on, you might see some other, examples where I don't have the labels, and it's a, different type of prediction scores. So that's basically kind of a single input view. And you can also switch different models, in this case, in app workflow. If I want to just use a very basic general, like just say, I haven't built any model yet. I just want to try, Clarifai's model. So this general model will tell you skate, girl, winter, it does a pretty good job. And then let me just try a different one. In this case, yeah, and maybe, adult woman, so it recognized pretty well. So you can also try some other kind of workflows, as I mentioned. Face sentiment is an interesting workflow. It crop out the face, and it basically does 3 things when we talk about workflow. You remember, it has different nodes. So the first will be a face, detection. Then we crop out the face, and then we do a classification on the sentiment. So whether it's happy or neutral or angry. So let's say in this case, it should be doing a pretty good job. Okay, it doesn't look that sad, but as you see, the score is pretty low. In this case, it's hard to tell. But if I try to find a happy image, let's say in this case, maybe I'll find a different input in this case, so I can see a little bit better. So I'm gonna remove this concept. I'm gonna find a face here. And let's see what the workflow says. Okay, the sentiment, is pretty neutral in this case. Yep. So that's basically some of the things you can do with this app workflow. Now going back to what we just mentioned earlier, you can have this kind of what we call a single input view. You can label your data. You can see, if you already have a model, what the score looks like. So you can also move on from this kind of explorer to a model mode. In the model mode, you can create custom models, but you also have a number of pre-built models at Clarifai. We have a long list of really interesting models you can explore. Of course, you can filter, if you want to get visual detector, or if you want to have a text classifier, for example. And we also have some pre-built workflow as well under Clarifai. So these are all kind of our pre-built models. But if you want to create a custom model, you can click here. And what we do is usually I create a really quick just transfer learn. Oh, sorry. So in this case, I'm just want to show you again. So let's just say in this case, you want to have, build a model. There's a button here, create a custom model. There are sorts of custom models we offer, but typically the context-based classifier is the transfer learn. You can quickly just fill in a few things, the IDs, the models. I'm not gonna recreate the model because I already built one, but I'll show you what I already set up in this case. If you wanna, in this case, I already set it up into a quick kind of transfer learn model to differentiate between factor workers versus skaters versus tennis player with a ray trace. And I have all the concept there. And then I can click the train and then train the model that way. So so going back to the Explorer, if you want to see the details of the model here, you can also see some of the details in terms of what the input I have for each concept, the version I trained. You can also see the evaluation results, and you can also do some quick, false positive and false negative and precision recall curves. There are a lot going on there to help you, improve the model performance. And we also offer, of course, this is to create a custom model. We also offer like a deep train model that is not transfer learn. So custom model, we have a transfer learn model. In this case, the context-based classifier, but we also have deep train model, for example, visual classifier, visual detector, for you to kind of train the entire network. If you entire kind of neural network instead of just the last two layers of the transfer learn. So for the deep train model, you need definitely a lot more. Generally, thousands of labeled inputs if you really want to do it that way. And I'm not going to spend time to do that today because it might take hours to train, but we do offer the capability to do that. And so that's basically what we cover in terms of the custom model. And for the next 2-3 minutes, I want to just show you our kind of labeler product. So here is our labeler product, and then we also offer the label force, which is a human worker for labeling. And in this case, we have number of functionalities. You can create a task based on inputs image you have. You can have different workers assigned. You can review. You can look at the stats and metrics. In general, we have a pretty large kind of a labeling team with the instructions, and we offer the software, software labeler management type of layer, but also the you can bring your own label workers, or we offer our own kind of label force as well, the human workers. And in this case, my colleague shared a really nice kind of a labeling app with me. Just imagine I'm going to help labeling some of the, the inputs here. So I click the labeler here, and there are a number of tasks. And this Park Life is a interesting task and is assigned to me. And I'm going to click into it and see what I need to do. So in this case, we have interesting concepts such as cycling, dog walking, pushing stroller, rollerblading, running, and walking. So these are all kind of creative concepts. And my job is to help label, input by input. Well, the nice thing about it is I don't have to start from scratch because luckily, my colleague already used a nice trained model to help me to do the AI assist labeling. So what it does is that the model will have a probability score, and if the probability score is high, then I'm pretty confident that I can just follow what the model says. In this case, I don't have to draw my own bounding box. I don't have to, spend a lot of time if there are many of them on this input. I can just I can just simply use the AI assist, and in this case, do the labeling. In this case, so now I have cycling, and the model does a pretty good job also detecting a runner. So I'm gonna have the runner. Of course, I can submit the inputs, but I'm not gonna do it today because this is, one of the collaboration tasks. Of course, you could, if you want. Let's just say go to the next image. Of course, you can always save a draft if you want to come back later. So in this case, also AI does a pretty good job, understanding this is a pushing stroller. And if I just say I have a concept along the way, I don't have it, here, you can also, add another concept in this case. Like, for example, you can draw the bounding box, and also you can draw a polygon if you want. And we also have segmentation mask, labeling as well. So in this case, I can, just imagine this is another stroller, maybe the AI assist missed, and then I want to kind of label it myself and make sure I capture that. I can also do that, but I'm going to delete it because I was just using it as an example. Imagine this is another stroller I missed, or the AI assist missed, and then I need to draw the bounding box and label it that way. But I'm going to just delete it that way. And let's just say in this case, also pretty good. It does a pretty good job basically identifying. Of course, you can, based on the score, you can reject it, or you can label as a negative. In this case, if it's not dog walking, in this particular case. So that's the AI assist. Of course, you can also automate on top of that. So what AI assist does is still most of the time you're labeling yourself, but we could also have another step of automation, which is the active learning. What it does is you can basically set up a job that you will, if you have full confidence of your model you build, and you want to use that to label the data, then you can set up a threshold. Let's just say anything above 80% or 90% probability just automatically labeled by the model. And anything below that, we'll pass it to the labelers to do the manual labeling. And in that case, and then after you have high confidence score data labeled, you can train the model to get better and better. So this is human in the loop, or software 2.0, where you can constantly improve the model and gradually kind of phase out that human in the middle in the labeling process. So this is also pretty interesting kind of use case in active learning. I do have an app of that active learning, but it will take some time to actually go through. Maybe I will just show kind of the workflow really quick. So this is a active learning workflow. As you see, there are 500, or there are actually thousands of concepts, and there are millions of inputs. So in this case, there are several models we need. You need to set up a threshold. You need also to set up a concept cinemapper. Basically, it's like similar concept. You can also set up a random sampler. It gets a little bit more complex for today, but feel free to go to our doc page if you're interested, and reach out to us if you have interesting use case you want to give a try. So that's pretty much the what we want to cover today. And again, just quick recap. From pre-trained models, we quickly show you how to build custom models, whether it's transfer learn or it's a deep train. And we also kind of have another step of automation where if you have a cold start problem, you have very few labeled data, you can set up your custom model and then you can start to use the AI assist labeling to quickly bootstrap or label your data, and then to do the deep train later. So with that, I think that's pretty much all I have for today. And again, happy to answer any questions, and feel free to reach out to me if you have any additional questions and comments, and please sign up our platform and start your low-code, no-code AI journey.